Okay, cool. I was trying to like.
I support your life.
Okay, great. Yeah. Have you been here?
My brother-in-law was coming
How we doing?
We're live.
How do we fix that?
I'm not sure because it's related to his actual input.
Oh, it is. Yeah. Yeah, it's got nothing to do with.
There's nothing I can do about it because I presented last night and it was fine. So it has to do with it's basically his
Orders right.
So it's got that going. The story's kind of the original call I did.
So I fixed it for you.
Oh,
It's all good. It was just, it's probably the fact our VJ is going dead.
I mean, so many people today. What was your name again?
Michael.
Michael.
Nice to meet you,
Sorry
Andrew.
about that.
Do you have a business card? Or a card of any type?
Yeah, here.
I want to be able to send
Corner and data science card. You know, we're a volunteer organization, so I just put them on my home computer.
Great.
So how do you want to start? 1 o'clock exactly? 1:01?
Yeah, probably one. My co-founder will
do
the
intro?
the intro.
Okay. People are a few comfortable seats over here that they can sit in.
It's right here. Yeah.
Keep them up.
All right, let's get started. Hi, my name's Eric Gross. I'm the co-founder of the Tech Academy, and now I have light shining through my body. These things are always so bright. And I look down at what's being broadcast to our students on the internet, and it looks like I don't even have an arm anymore. So I want to tell you how much I appreciate you guys coming to these things. We put these on for the benefit of the community and also obviously to let people know about the Tech Academy. And it's always a joy to me to find out what kind of unbelievably interesting and cool and awesome people there are out there in the technology industry, and how many different viewpoints there are, how many different jobs there are available, how people break into the industry, what the careers are like. It's just a really, really interesting area for me. And so when we have people come here who aren't members of the school or students of the school, it's just one more opportunity for myself and our students to be exposed to a variety of different viewpoints. So that's what we have today, and it's one of I think great interest to people who are trying to break into the industry or have been out of the industry for quite a while and trying to come back into it. Ostensibly, the talk is about machine learning, but one of our presenters today, Andrew Ferlitsch, actually is encountering that same thing of coming back, back to the job market after about 18 years of being away from it. And I think we can all acknowledge that a lot about the job search changed in the last 18 years. Just the internet alone, as a factor, changed a lot of things. So their talk today is about machine learning, and it's awesome. But if you're involved in that job search process, I highly encourage you to spend a little time afterwards. Pick his brain, talk to him. He's got some great input. And I interviewed him this morning for our podcast. So in a couple weeks when that podcast goes out, you'll have an opportunity to learn his story and how he approached the job search process and getting involved with meetups and networking and forming connections. And it's a great story. So without further ado, I'd like to introduce our speakers today. Andrew Ferlitsch is going to talk about machine learning. He's with the Portland Data Science Users Group. And when he's done, his friend Ernest is actually going to step in and give you a little more hands-on as well. Please help me welcome Andrew.
Thank you. So I want to make sure I don't stand in front of the screen. I'm sure everybody can see it. It's great that you all have attended. I'll just add a little bit more. We're the Portland Data Science Group. We started as a meetup, and we've expanded into being an organization now. We're running 10 events on average a month. And recently, we've started reaching out into the community, doing things actually outside of our event structure and more like this in the community. One of the things we've recently added is the idea of a local roadshow for machine learning. And the idea here is not to try to teach everybody in a short boot camp all about machine learning, but enough to give you an introduction to it, to aid you in that decision if you're thinking of moving into that area. Is this something I want to do, and what would the expectations be? So I'm going to spend the first part covering things more at a fundamental abstract level with no coding. Okay. And then the second part, Ernest here, he's going to dive a little bit, not too far, into examples of coding examples using Python. So let's get started here. One of the things I hear from people when they talk about machine learning is there's a confusion: is machine learning data science, or is it AI, as in CS? And it's actually a combination of the two. Historically, what we think of machine learning would have came from the data science area, okay? But in recent years, with the development of neural networks, natural language processing, and all these other techniques, they've become front ends to traditional machine learning models. So that's how they're now married together. Okay. There's various categories in machine learning. The ones that people are most familiar with, or tend to be most familiar with, are predictive systems or recommender systems. Like you're on Amazon and it recommends things for you to look at or things for you to buy. Targeted advertising, when you're online, what ad to serve in front of you versus another person. And that's what falls more into the regression classification area for prediction. Another area that you're hearing a lot about today, right here is the phrase neural networks. Neural networks are really good about recognition, and particularly recognition in the real world. We all hear about computer vision, being able to tell the difference between a cat or a dog, but what's more important is an autonomous vehicle knowing that's a stop sign, or that's a yield, or that's a small child. Okay. Another big area people are becoming familiar with is natural language processing. and that's in the speech language area. And so those are all those products you're talking with Siri or with the Amazon Echo and all that. You're getting familiar with them and comfortable, and in many ways you've forgotten that they're AI and machine learning, but they are. Okay, so just part of your life. And then reinforcement learning is a new emergent area in this, and that deals with robotics. Okay, and the idea is that robots are going to have to operate in the real world just like you and me. They're going to have to encounter things they've never encountered before and learn how to interact and deal with it. And in many ways, trivial things are you don't even think about, like a robot learns to say go up and down a sidewalk, okay? And one day there's a little pebble there. Well, that pebble is actually adversarial. It's not supposed to be there. It needs to recognize that and deal with that situation. Some of the examples out there of solutions people use in machine learning. So on the classification side, or the statistics side, so classification is like telling the difference between a category, elements in a category, like fruit. Is that an apple? Is that a pear? Is that a banana? Prediction is trying to come up with a probability or a likelihood. So how likely are you going to live, for example, or how likely are you going to buy that product? Okay. Forecasting, being able to predict the future, what's going to happen in the future. A lot of people, of course, hear it about climate change or about the stock market. Okay. Recommendation systems, again, that kind of went in line with the prediction, just a little bit different. Looking at your patterns, individual, not just group patterns, but your patterns within a group, and based on that, trying to make a recommendation that's very accurate, that has a high level of certainty, you would actually be interested in that product. And then association. This is one I always like. I like. Association deals with patterns, particularly buying patterns. And so when you go to a grocery store, one of the things we know through data and association rules that if you buy bread, you're almost certainly going to buy milk. Okay? But when you go to the store, for some reason, bread is on one aisle, the first aisle you come in, and the milk is on the exact far end. And they do it on purpose. Because if you get bread, you have to walk past every other aisle before you get the milk, forcing you to look at it. There's other tricks that they do every day. It's very common. If people buy eggs, they're going to buy cheese. Okay? So you might think, well, they might put the cheese right next to the eggs. Well, actually, if you pay attention, usually the cheese that's next to the eggs is the high expensive cheese, not the commodity cheese. So if you're kind of in a hurry buying your eggs and you don't want to go way over to another part of the store, you're likely to pull that higher priced cheese and they just upsell you. Okay. On the computer science side, we have computer vision. Again, I gave that example of road signs. Voice to text, your speech recognition, you're talking to Siri, you're talking to Alexa. Translation, just being able to understand the difference between dialects and different languages. Okay. Dynamic adaptation, that's in automation. So again, I gave the example of robots, but that's also true in factories. We hear about robots being used in factories for automation. Well, what if you change your line? Okay, something changes about your product. You don't want to have to pull that robot out and put another robot in. So there's a big emphasis to have robots that can dynamically adapt in a factory to a new form of automation. And finally, audio recognition is a big area. In the UK, for example, they have a system throughout the city of London that can recognize gunshots and recognize exactly, if you think from a GPS coordinate system, whether they occurred, and you can immediately dispatch, police out there. So that's a large variety where machine learning and AI in general are impacting our lives already today. And here's where it's going to go, and I think kind of the important thing here is complexity ladder does equal the salary ladder. currently what's fairly mature right now is using these techniques in marketing and sales and text classification, so the money is very good there. Moving up the ladder, human interface, being able to recognize your emotions, your intent, facial expressions, and computer vision overall. You move further up there in areas that are more emerging, factory automation and industrial level 3D printing. The pace starts to get really good. Finally, everybody, of course, always hears of autonomous vehicles. It's generally considered the top end, but it's actually a real further out there, space, stratosphere. And the reason is you got to develop, if you're putting something in space, you have to assume no human being is ever going to see that thing again, and it's going to encounter environments and situations that it has to adapt to, and it's going to be exposed to radiation, and it needs to know how to repair itself. And they're too far away for us to communicate. Just to communicate to Mars and back, that takes 8 minutes. Okay. So I'll get to the basics. So machine learning is about using data to train a model. So you've collected up all this data about something. Just a simple example, you got weights and sizes and color about fruit, okay? And so what you want to do is you take this data and you're going to take some of it, this data has been all labeled, somebody's gone in and said that's an orange, that's a pear, that's an apple. And you want to take part of that data and you make that training data, and then you want to take another part of that data and that's your test data, okay? And the idea is to use the data, the training data, to train a model, okay? And that model becomes your predictor, okay? And then the test data is ran through the model to determine how accurate would this be if I used it on new data that I don't know what it is. I don't know right now that's an apple or a pear. So in machine learning, there's generally two categories. They're called supervised learning and unsupervised learning. So supervised learning is when our data, we know what it is, and we call that, it has a label. So again, if you can kind of imagine having data about weights, sizes, and color about fruit, there's a field there that says what type of fruit that is, and that's called the label. Okay? And if you have the label, you know what it is in your training data, you can then use supervised data. Okay? Unsupervised learning is when we have unlabeled data. You've collected a mass amount of data, okay, like from sensors, but no human being has gone in and figured out what those elements are. So you have to use a different technique to basically map that data into clusters, and then eventually a human being can come in and say, that cluster is an apple, that cluster is a pear. So in supervised learning, this is supposed to be like an example of what you might have in a data set. So a lot of you are probably familiar with things like CSV. You have a bunch of rows of data, with columns separated by commas. And typically in a data set, you have this concept, these values or these columns, we call them features. So that's the feature of the sample, okay? And then the label is what the sample is. And that's typically what we call a categorical value. So it's a category. Cat, dog, pear, or apple. Your features are usually going to consist of some real value, like a number, or they might be categorical themselves, like a color, red, green, blue. Okay? And so, kind of showing the difference here. And one of the things you'll find looking at your data is you want to really reduce, because you could be working with mass amount of data, you have this concept of entropy and information gain. And many times less is more, okay? So you kind of want to start identifying your data what stuff contributes to me predicting what it is and what stuff doesn't really contribute. Okay? So I make a little example here, and a banana and an apple, well, quite frankly, both of them come in the color of yellow, and so it has very little significance. That's not going to contribute much to predicting from the features, what type of fruit that is. On the other hand, is weight, width, and height are much more significant. Historically, the most simplest machine learning method is called the decision tree. Okay, so this is classifying things in a tree structure. Usually what you do is you take a first feature like this color, and you then split it down, with all the possibilities. So it could be green or yellow. Okay, so all your data is coming, every row of data is coming through here. For every row is switching one direction or the other. Then at the next level, you take that same feature at every branch and you again split it, just like a tree. Again, and then you split it on some criteria, and this assumes you've learned this criteria. So here we're saying it learned at the threshold of 4 for its weight, 4 ounces. I should go this way, okay? That most of the things are more likely to be a banana, for example. Or this way, they're more likely to say be an apple. Okay, and you keep doing that, and you can see that the more features you have, the bigger and bigger that tree is. Okay, so that's another reason I talk about you really want to look at your features and actually get rid of some features that aren't contributing that much. It'll make the tree smaller. But at the very bottom, you finally have your classification. So as the data comes through, works its way through the tree, eventually it gets to a leaf, and the leaf says what that is. Okay, now I kind of alluded to the idea is about pruning, that is going through a feature list and eliminating data that isn't going to contribute. So the example I was giving was that color had very little significance. So if I prune that out of my data set, I got a smaller data set, it's more workable. And after I prune it, you can see my tree is a little less complicated. Okay. Now, people are free to interrupt me if they want to ask a question. I know people are at different levels here. Okay. There's another technique. It's much more modern. When it comes to decision trees, as I explained, you could have those vast trees. They have this idea of an ensemble method where you use what's called decision stumps. And the theory behind decision stumps is that for each feature, I'm just going to make a decision based on that. Okay? Based on weight, here's some threshold. Below that threshold is a banana. Above that, it's an apple. Separate one for width and height. And of course, every one of these individually is less accurate, but the theory is as long as they are better than random, that is that they're 51% or better, if I collect a whole bunch of these up and I do a majority vote, I will actually get a more accurate model or a more accurate prediction than I will if I build a full-fledged decision tree. So that's another thing people, that's kind of new, is knowing how to build ensemble methods. So, one of the first things that people get introduced to in supervised learning is the concept of linear regression. You probably covered this in high school math, and then thought to yourself, like me, when I went to high school math and I did linear algebra, it was great, it was over, and I thought I would never ever see this again in life, and it was kind of correct. Almost 30, 40 years later, suddenly I'm supposed to know it again. It's like, what? All right. Now, linear regression, if you remember, it's all about fitting a line, okay? And it's the simple form is always the old formula, y equal, you got some constant here or a bias, and then your variable and the slope, okay? So think about it, you got all this data, and you throw it on a 2D graph. That's your scatter plot, if you remember it. And you're trying to create this line that best fits all those dots. That's most representative of it. You know, there's always some offset. Nothing ever starts at 0. So A, your constant there, is the offset. Where's that anchor in this graph of the line? And your B is the slope. And what you're trying to do is predict or come up with a B that best fits this. Okay. The typical way people did it was you have this concept of a loss function. So if you think I make a line here, I got my scatter plots. I want to predict or estimate the loss. That is, I have a real value here. Here's my predicted value. How wrong am I? And then sort of add these up, and you want to bring them to a minimum. Okay? And wherever the slope that minimizes that the most, you say that's the best fit line. And typically, historically, if you remember your linear algebra, you use the mean square error version. This is about the only math I'm going to show you. I kept it simple, so you know it's just the difference between the real value and the predicted value. You square it, you sum them up by the number of samples, and then you divide it by that number of samples. The reason they do the square here is the further you're out, the more you're penalized for it. The closer your dot is to the actual one, the less you're penalized. Okay. So at this point, I just want to tell you, don't worry all about all that linear algebra and that unless you're going to be somebody who's actually going to be developing a neural network or new technologies or a new way of doing this stuff, because the libraries now do all the work. Okay, so don't be that frightened. All right. I just made up pseudo names. It doesn't matter what language or what library you have. All of them follow this path. There'll be something in there, a library for splitting your data. So you give it your data, you give it some percentage. I want 80% training, for example, and it'll return, you know, a part of that data as your training data, and part of it as your test data. And then you'll have another library about training the model. You'll pick what model you want to use to train on, but effectively there'll be a library for whatever model that is. You'll give it its training data, and you'll identify where in that data is the label, okay? Because that's what you're learning to predict. Then, once it's developed a model, you'll take that model and you'll actually run your test data in there to actually, based on the test data, you're going to predict the results. And of course, you know the actual results, okay? And so finally, you'll have some other library that will measure your results by taking your predicted results and your actual results and figure out how good is your model. And you might hear phrases from time to time called hyperparameters, and that's people coming in and sort of tuning and changing parameters here to get a better predictor. Okay. So in unsupervised learning, we don't have a label, and that's a much harder problem, and that might not be so uncommon. Just think if you got this big sensor array out there, out in the environment, it's collecting all kinds of things: temperature, sound, humidity, who knows? It's just coming in vast amounts, and you're just collecting it. You know, it's been going on for a while, and one day your boss comes in and says, "So, what can we learn from this data?" And you got a terabyte of it. You go, "I don't know." Well, now you're into what's called unsupervised learning. I want to learn something from this data. Okay? And that just means no human being has gone in and put in the label field. So the computer is going to have to learn it now. In college, you probably covered k-means. Okay? So if you took any linear algebra in college or statistics, and it's the idea is, again, I have a scatter plot, and I'm trying to group the dots, my plots, into clusters that are most related, you know. And for example, let's say these again represent apples and bananas. I know there's only 2 categories, so I'm going to try to find 2 clusters where these samples best fit more into that cluster than they would over here. And the simplest one is the distance. You can see how these guys are closely related together on this graph, but they're far away from these guys and vice versa. And that's the basic principle about clusters. Okay. Now k-means, instead of visual, because you may have, you know, a terabyte of these samples here. The idea here in this method is you start with 2 random points on your graph, and then you go through and you look at every sample and you assign it to one of these initial cluster centroids based on the shortest distance. So this example here is closer to him than it is to him, so I say you're part of this cluster. Okay. So on the first round, you get these sort of rough clusters. And remember, they don't yet look like that. Okay, but we'll get there. What happens now is you take those two new clusters and you take all the samples in them and you calculate a new center of that cluster. So as you can see, I've moved the centers here, okay, based on that. Okay, and then you repeat the whole process again. You look at all the samples, who's closest. And what happens is these clusters gradually move, separate, and if you do it enough times, you'll get to what's called convergence, where nothing moves again. Okay, oops. And that'll result in looking like this. Okay? So I'm going to move ahead. So another thing you have to do in machine learning is this concept of preparing a data set. Everybody here is familiar with the concept of garbage data, garbage in, garbage out. Okay, you're working with vast amounts of data that comes from vast number of sources. Who knows what's happened to it? You're almost certainly going to have some level of garbage in it. So you need to prepare that data set. Okay, so you know the first thing you're going to want to do is clean it up. This is sometimes called data wrangling in the industry. You want to be able to fix unreadable entries. You know, the data might have just it's got text data in it. You know, it may have came from a different character set and it's just been misencoded. And you have to be able to identify that and correct it. You know, people deal with CSV files, they're comma separated. Sometimes the data that's put in there has a comma in it itself and it's not been properly double quoted, so you get misaligned. You need to be able to fix that stuff. Also, it's really hard for a machine learning algorithm to take a row of data and then one column is blank. What do I do with that? There needs to be a value there. So you need to be able to identify blank fields and have a policy that fits the model you're building of what you could say artificially going to put there or synthesized to put there. So common things people do is, hey, if I got this one column and here and there's a blank, I'm just going to get the mean value of everywhere I have data and just arbitrarily put that in. Sometimes people are really clever and they actually use machine learning. Okay, I'm going to treat the missing ones as a label I want to learn, take the data, not learn the label, but learn that value. Okay, so I don't know if you can understand that concept, but it's basically taking the rest of the columns and trying to, and using where there is a value, build a model to actually predict the missing values. And then you fill them in, and then you build a new predictor. Conversion, okay. In machine learning, everything actually needs to be what they call a regressor, which is a real value, okay. One of the problems you have is when your data is categorical, and categorical just means that it's one of a set. You know, I've been using the apple, banana, pear. So anywhere you have categorical data, you have to quote convert a technique they call dummy variables. So it gets expanded out where every category becomes its own feature. And then for your data, one of those fields will have a 1 in it, okay? And the other ones would have a 0. I probably should have put zeros because you never have ones. Another thing about machine learning, you want all your data to be proportional to, all your features be proportional to the other ones, okay? So they don't become, they don't overweight the model, okay? So if you think about it, if I'm doing age, you know, and it might be, say, 18 through 99, you know, that's about a range of what, 80, right? But what if another field is income, and I go from $1,000 to you know, 250 million? Okay, that huge range will dominate my model, okay, and will make the age thing be less significant. So one of the things we do is anywhere we have a numerical range is we want to make them proportional to each other. Okay, and that's called normalization or standardization, and so that they have the same proportional range. Okay, and there's again, in college statistics, there's a very simple formula for that. There's only other place that will show it, so that's another thing used. But again, as I mentioned, the libraries do all this stuff for you. And that's all it on the first presentation. I have some more. So does anybody want to ask a question? Okay. Excellent. Okay. This is to introduce you to another way of programming, and you'll find it common in reinforcement learning and in robotics. Most of you have brought up, you know, with a certain style and how you construct a program. And when you move in that area, that's going to change. And that different style is called dynamic programming. Okay? So people always ask, what is it? And it's a method of solving complex problems by breaking them down into subproblems. And you want to remember the subproblem and then reuse the stored solutions. Now, when people say this, the first thing people think of, isn't that the same thing as writing a function, writing things down with functions and calling them, which is traditional programming? And it isn't. And in a moment, you'll understand why not. Okay. But think of it this way. I got a complex problem, and I broke it down into subproblem X, Y, and then X again. And I go out, and during execution time, I'm going to solve X, and I'm going to save this solution in the solution space. I solve Y, I'm going to save it in the solution space. Then I re-encounter X, and because it's in my solution space, I don't resolve it, I just reuse the previous solution. Okay? So in traditional programming, how it's different is the program doesn't break down into subproblems. You as a programmer, you pre-know the problem, and you predetermine what the solutions are, and you design and code them. And then you encapsulate the solutions to a subproblem in a function. In dynamic programming, the solution is discovered, not coded. And that's the big difference. So think of a robot. It's got to discover a solution to a problem. You as a programmer have never programmed how to handle that situation. So in traditional programming, that chart is almost the same, but the difference is instead of these discovering solutions and putting it in the solution space, is you've already coded ahead of time the solutions, and now I'm just recalling them. So I'm going to give you an example. It's the least coin problem. And that's a problem where if I give you any dollar amount, what are the least number of coins you can carry in your pocket for that dollar amount? Okay? And I'm going to first start with a traditional solution. You as a programmer, you want to come up with the algorithm ahead of time and break it down and make a function or functions out of it. And if you take our currency, 1, 5, 10, 25, there's a pretty much a very straightforward algorithm for it that will work every time. And the examples I gave here for 8 cents, you know, it's a 5 plus a 1 plus a 1 plus a 1 penny for 4 coins. 23 cents is 2 dimes and 3 pennies for 5 coins. And it's really simple. I just have an accumulator, and while my sum, trying to come up to that, is still not up to the amount, I get the next largest coin less than the remainder I haven't solved for. I add that coin to the sum and bump the number of coins that I'm accumulating. Now this solution works because all these coins are multiples of each other. But if I change the coins, 1, 4, 5, and 15, and you apply that algorithm, see, you think it would always work, actually will give you the wrong answer. In this case, 8 cents, the least number of coins are 2 4-cents, but that algorithm would have started with the largest coin that would have fitted, 5, and then forced to select 1, it would have came up with 4 coins. Same thing with 23 cents, the best solution would have been a 15, plus the 2 4s for 3 coins, but that other algorithm would have started with a 15, and then with a 5, and then forced you into the 3 pennies. So some things, if you don't know ahead of time about them, you want to actually discover a solution. So in this example, to demonstrate dynamic programming, I'm going to use a search tree. So it's basic graph theory, okay? And I'm going to do a breadth first search on my search tree. And the reason I'm going to do a breadth first search is it guarantees I'll find a solution at the shallowest node, and the shallowest node will equal the least number of coins. Okay, so at my root, I make my first decision. Okay, I'm trying to solve for 8 cents. So I create nodes, one for a penny, 4 cents, 5 cents. I didn't put a 15-cent here just because it's bigger than 8 cents, so I could trim that off. So that's my first level of choices, and none of these solve the problem yet, so I'm going to go down a level. Okay, so first I try to solve for the 1 cent, okay, and I'm actually trying to solve for the difference, that is 8 cents minus 1, so I'm actually trying to solve the sub-problem 7 cents here. Okay, so again, I can pick a 1, 4, or a 5. I don't pick the 15 because it's bigger than 7 cents. Okay, and my sums so far are 2, 5, and 6 cents, so I still haven't found a solution. So I move on to the 4-cent one. You know, typical breadth first search. You know, I could try the 1, the 4, or I don't need 5 or 15 because they exceed the problem I'm trying to solve. Trying to solve 8 minus 4, which is 4 cents. Okay, and of course I'm going to discover the solution here, or the goal node, at 4 cents, and so that's my solution, doing breadth first search. So 4 plus 4 is 8 cents, which is 2 coins. What I'm going to do now is I'm going to have a solution space. Okay, so I'm going to put the solution to 8 cents in the solution space, and that's the solution, is 2 4-cent coins. So let's now go ahead and see how we can use this solution we've already discovered for 23 cents. Okay, so I start the same way. I've got a root of the search tree here. I'm going to solve for 23 cents. Okay, this time it's a dollar amount that's high enough I can put all 4 coins at the first level, but none of them are a solution yet. But if we look really closely now, instead of expanding all these nodes, I know the subproblem here is 22 cents, and is 23 minus 1. The subproblem here is 19 cents, 23 minus 4. Here the subproblem is 18 cents, and here, 23 minus 15, the subproblem is 8 cents. Well, I already have a solution for 8 cents. I don't need to expand any of these, I just need to pull it in, and I'm done. So that's kind of an example of dynamic programming. Yes?
Wouldn't you still need to do like one more layer to make sure that you don't add like some solution that ends up being far quicker than more efficient than two extra concepts?
Yeah, I understand because I'm more than one level down here. Yeah. I'm going to show a little more advanced here, so that should help answer that question, because that question always comes up. Okay, so let's look at this more deeper. Okay, I kind of did it really quick to make it. So really what happens is you're going to store all your solutions at every level. Okay, so when I first did this 8-cent one, I did 1, 4, and 5. I actually going to put in my solution space 1, 4, and 5. So you're going to see point 1, 4, and 5 over there. Now, if you imagine, I'll just go back quickly, because I'm just showing part of the graph. So if you remember this picture, I'm just going to show this solution space here, not this part. Right there. Okay. So I've done the same thing. Now that I have 1 plus 1 for 2, I have a solution for 2 cents, so I'm going to insert it in. Okay. 1 plus 4, I have a solution for 5 cents, but I already have a solution for 5 cents, and it's more optimal. So I know right away that because this is less shallow, it's less optimal of a solution. So I'm going to keep the old one, and I can automatically put in this. Any solution below this will be less optimal for a solution than anywhere else on the graph. Okay. And then, of course, here's that part where I found the solution on the 8-cent coin for 8 cents. Okay. Now, when I start the 23-cent problem, I have the 15-cent one I encountered first time. So I'm going to add it to the table. You can see I've transferred all these other sub-solutions to the new problem. Okay. And this allows me, I forget how to say this, none of these guys yet got more, here's the answer to your question, has got a solution to these other numbers. So they would require at least one node that's a sub-solution, and that solution would have to have nodes below it. So anybody else, to answer your question, would have to have a solution that was at least 2 nodes or more down. So no other solution below here could be at any shallower depth than this solution. So there's no need to search them anymore. It's just a graph theory thing. And that's dynamic programming, an introduction to robots. Yes?
If you had a 6-cent coin and your solutions for 10 cents, is that?
Well, then you kind of have to redo it, don't you? You invalidate your cache. If I add a new coin type, then all my solutions I've accumulated so far become invalidated.
And so if you have 2 solutions for one number, basically 10,
Yeah.
and then would that work as well? If your solutions are the same?
Well, if they're both least, you're going to pick one of the solutions. If they're both
Yeah.
optimal, you just arbitrarily pick one. It's just the concept of optimality. Oh, there's somebody back there.
Kind of jumping way ahead of Ben here in this presentation, but since I kind of have to.
Okay.
Correct me if I'm wrong, but I don't see much junior level position for machine learning. So how do you want to actually get into that? You have to do it yourself for so many years and so many projects before you can actually apply?
Well, I can understand what you mean. I wouldn't necessarily disagree with our junior level positions. A lot of companies are now realizing we need to start moving into this space. They don't know how to, okay? And yeah, they like to hire somebody senior, but they also tend to like to hire other positions where people are going to grow into it, and that's where they look for those junior positions. They do look for somebody having, some level of training. You can't really rely right now on people, learning this in college. Most colleges are just starting these programs. Okay, so most of the employment base for the next few years are going to be people learning it after college. So in addition to, learning the basic skills at a coding school, getting involved, a lot of things employers are looking for are getting involved on Kaggle teams, if you're familiar with that. Kaggle's a website where they have machine learning contests, and you can win things including money or swag, and people across the United States form teams and compete, and you get a rating, okay, and so that's something employers are looking at. Okay.
Just on that note,
There are a lot of great engineers who just pick up machine learning engineering as you go, and even the guy who Elon Musk appointed as the CTO of OpenAI had not had any machine learning coding experience up until pretty recently before that. So he'd just been the CTO at Sprite. He was a great coder, but so you can pick it up if you're. It's fun. Yeah, and like employers don't really care if you went to Stanford or not, as long as you can actually do it. And I'm hiring.
They might in 7 years. You know, it's just mass number of them coming out, but not right now. I'm going to do one last one. So for all those people who hear about image classification, you know, basically looking at images and figuring out what's in the image, you know, the big buzzword is Tensorflow, and it tends to sort of scare people, you know, so this is just a simple introduction to make it feel a little less scary, okay? So what is it? Okay, well, Tensorflow is basically an open source machine learning library that was released by Google 2 years ago. It's based on Google's Inception V3 neural network. This is the image that they put out there on the net of Inception V3. It's known as a convolution neural network, and in the case of this, that means that not only is it a neural network, but it's got some front ends to it, and those front ends part is the part we refer to as convolutional. I'm not going to explain it, but you can look it up. That takes an hour. Okay, but it's available both in Python and C++. Okay, so that's what TensorFlow is built on top of. You're going to use. And so to understand what a tensor is, I start with the basic. What is a vector? It's something actually you're all familiar with. It's just an array of numbers. Everybody knows what an array is. Fill out what numbers, that's a vector. Okay. In machine learning, a vector holds the feature values, okay, for a sample. So if you remember earlier when I was showing you data sets and they had all those features, okay, take one row, something like that, okay, you got a vector. The next level up, okay, it would be a matrix. So a matrix is just a two-dimensional array of numbers, okay. And in machine learning, basically a matrix typically is just a set of samples. So in one direction, you know, your rows are your samples, and in another direction in the matrix, those are the values in your columns. All right. So finally, we get to a tensor. So a tensor is referred to as a high-dimensional array. Okay. And this happens when a feature, a sample value, is not a single number, but is actually itself a vector or some kind of composition of other values. This typically happens in things like natural language processing. So when I talk about a word, you know, it actually, we have what's called a word vector, where I might have its association to other words or other things in the text. Okay, so think of them as like complex elements that go into a value, and that's what a tensor is. So it's just one level above a vector and matrix. Another thing people find a little confusing is the concept of design and run. Okay, so in TensorFlow, you design a graph. Okay. And that graph is going to solve your problem, and then you run the graph. Okay. So the design is your symbolic representation of your model, and at runtime you're going to bind the data to your symbolic representation and run it. Basically, bind the data and execute and get your output. Okay. So I'm going to start real simple. So in TensorFlow, you have symbolic representations as a graph. So we'll start very simple. You could have two tensor variables. They're just variables. And the fact that I say it's a tensor means it could hold a scalar value, it could hold an array, it could hold a matrix, or it could hold a matrix that consists of vectors or matrices or so forth. Okay? You have some node that's an operation, and of course you have another node that is the output of that operation in itself is a tensor. So here's a real simple Tensorflow. Matrix multiplication, having two matrices, you're going to multiply them against each other. Okay, so your two variables here may be matrices. The operator may be that you put on this graph is a matrix multiply, and your output will be a new matrix that is the multiplication or the dot product of those two matrices. Okay, stay simple here. So in Python, here's an example where, just a simple coding example, I'm going to define two constants. So TensorFlow is referred to this alias as TF here in the import command. So basically I'm saying from the TensorFlow library, create this constant 1, this constant 2, assign them to these two variables. Okay? And that's all I've done. So I could then tell, and that's actually a graph, so think it was just two standalone nodes, not really doing anything. And then I run the graph, I create a session, and I run it. Okay? And what I would get out of that would just simply be the values 1 and 2. So you get a tad bit, start getting a little more complex, but not too far. Okay? So this time I'm going to take those two nodes, and I'm going to attach them to another node, an operation node, and add. So it's the same thing, but I've got a new variable x3, and x3 is going to take as input x1 and x2. Now when I run the graph, I'm going to tell it to solve x3, and it will actually work backwards in the graph and then execute. So if I solve for x3, I'm going to get the answer 3. Okay. So in TensorFlow, you can also do placeholders. Okay, so you notice in the other ones, I preset those numbers, that was 1 or 2. But what if I don't know them until runtime? That's what they call as a placeholder. This tends to confuse people when you first get into it. It's just, you're just saying, I'm doing late binding of my data. At runtime, I will hand you the values of those variables. And again, it's the same thing. I'm going to run, this is my design in the graph, I'm going to run the graph, solve for x3, but now I'm binding the values of x1 and x2. Okay, and again, they'll produce the same result. So we'll start getting a little bit more into it. Again, in TensorFlow, you can bind any type of tensor, so a scalar value, which I was showing you, an array here I could bind in there. I could bind a matrix. So if I did a scalar value of this add would just be a scalar add. If I did vectors, it would be a vector add. If it was a matrix, it would be a matrix add. So in this example, if I put those in, it would do the add of these two arrays, and you would come up with that. Well, actually, it's a simple matrix addition, just one level. Okay. Of course, we're talking about a graph, so we could have lots of operations, lots of nodes. So in this case, I'm just showing what I started with at first, two variables. I'm going to add them together. I'm going to have another node here that's a constant, and I'm going to multiply that constant against the matrix that was added together. And then I have some new matrix, which is my output. So this is fairly simple to write. So if you remember these two first lines are placeholders, I add them together. That's going to produce that node x3. Okay, I'm going to take x3 with the node, the constant 3, and multiply that against the matrix. That'll produce a new result. So I've designed this graph that you just saw, and now I'm going to run it, and I'm going to have that late binding of data there. Okay. So this is just to show you don't have to always use their function names. They also recognize what's called shortcut or inline operators, just like any other language. And then finally, the part I wanted to build up to is the old linear, the linear regression algorithm. Here I got my predicted value is going to equal my constant plus some b, my slope, times x, my variable. That's easy to represent. Okay, so you can see I've represented it there. Then I'm going to seed it with some data, and I'm going to run that crap, and it's actually going to produce my model. Simple linear regression model. We just did it in TensorFlow. Okay. TensorFlow comes with loss functions. Remember I told you when you're doing linear regression, you want to calculate your loss to get the best fit. Okay, so it's built in. This is that reduced sums that I showed in that earlier presentation. There's also what's called, a lot of people are kind of frightened when they hear the phrase gradient descent, okay, for much more complex models. You don't really have to worry about it in TensorFlow. We have one built in, and you just give it a learning rate. Basically, you give it its loss function. It takes your data, its predictions, and it keeps iterating through it until it minimizes the loss using gradient descent and gives you the best result that it can get, the best predictive result. So what I want to tell you is, like other things, don't get too scared, because TensorFlow, that level of TensorFlow, is for people who are doing research. People are coming up with new models, new ways of solving it, a better convolution network, and so forth. You as a programmer are actually going to use the tfcontrib.learn. It's a high-level package where all that stuff is hidden from it. So that's basically TensorFlow. Quick introduction.
So would Markov chaining be an example of TensorFlow model?
You could represent it as a TensorFlow model. I think of Markov decision processes, like using in a robot or something, reinforcement learning. But again, that is a graph. You have to, your weights here are your rewards, and then you also have to have a system of applying your discounts. But yeah, if you want to try to write that as a TensorFlow graph, you could. All right. This might be a good time to take a very short break, and I'll give time for Ernest to take over. Okay. Oh, thank you. So here's your video input. I will unplug me. So just let you know, this is our first time doing this, so at the end, any feedback about how to better tune it from the audience, we'd appreciate. I got one. Good. I got it. I'm at 15 minutes frame. Since I'm not the show anymore.
Yeah, go ahead and have some pizza.
Okay.
Jamie, how your pastor class to get for
I guess I'd rather not do that.
Yeah. Oops, sorry. Oh, you're handing me the power supply.
I have the... I can use that too. No, the other one.
Oh, you have this one?
No, I have this one.
All right. Yeah.
I ran out.
That's happening.
Yeah. But let me bring
You can help. You can help.
All right. How much time do you have? 1 minute? 1 minute?
Okay, to the subject.
Come on, when you're ready, let's go.
Sure.
Great.
I guess I already told you.
I have the absolute greatest, most experienced investment banker who is my law professor for startup finance and patent valuation. Is gonna fly in to do it with me. He is the most magically charismatic person in the world. Expert in like wowing VCs.
Wowing?
He's really done hundreds of startups.
You make a video?
What's that?
What are you looking for?
I'm just trying to get a spawn a bit bigger.
Increase the phone bigger so we can see that. Yeah, that's what we're doing.
Will you keep?
X-ray? It's if you go to X-R. So I got the name. I inspired the name. There's another startup doing a radiology AI that has superhuman performance, better than any expert radiologist, like finding technical help in medical education. So we're building that.
There you go.
AI for
Yep.
training.
It went bigger.
So every kind of training in the world is going to be on our platform next year. And thousands of dollars per engineer. And we're in talks with the industry dominating
Okay, we're good.
Remind me of your name again?
My name is Dennis.
service provider to
All right, everyone, we're gonna get started.
coordinate data engineering and data.
Hello, everyone.
Sell.
Brian? Oh, we're gonna get started. So we're gonna continue the presentation with Ernest and take it from there.
Okay, so my name is Ernest Bonat. Andrew called me a couple of days ago and said, could you come to the team and present something simple, you know? So I want to show you something very simple stuff, you know. I don't want to complicate your life, you know, for anything. What I do for a living, I am a software engineer. I do some consulting for many companies. I do software engineer and some data science. I teach online Python class and business statistics for fun, but I have nothing to do. So the question is, how can I answer the question? There is a lot of data science jobs available, and all of them are for senior programming. And I see somebody ask a question, all right? So what do we do? Okay, so you take a class, you take a boot camp, all right? And you get this diploma, whatever they call data science, or machine learning, and you have no profiling. So you apply for a job and nobody calls you back because you have no experience, all right? So what do we do? Nothing. Okay, so I want to give you this one idea. What do I do to get clients? I meet people around, go to the meetup group, meet many clients, and I said that I want to do a project for you for free, all right? So they get very excited, all right? Can you believe that? I spent a couple of weeks doing the project for this guy for free, yeah? I give a nice database design, nice documentation. He called me back, maybe not, maybe yes, and we're good. But I put the project on my profile, and I get a reference for this client. So, how do you get these people? There is an organization named, I think, here in Portland, named, they call the Hack University. They do a lot of free projects with the city of Portland. You know, the city of Portland have a lot of data, you know that, yeah? And as you already know, the government have no clue how to get the data, you know? So, you go there, meet these people, and trying to do some work for them, and you can put something in the profile, am I right? So, one recommendation, go to the user group, meet people there and find out you can do some research, am I right? So you can get some free project to be done. Because you have no experience, nobody going to hire you. I already tried many times, many of my friends, you know. So you need to do something that may be free and you can increase your profiling, you know. One thing is important is do some presentation, right? You can go do some presentation about something that you know, am I right too? Yeah, you can put idea presentation, something like that. You know? But it is very hard, you know. It's very hard when you want to find a job and these people looking only for the people that know stuff, you know. And even you are okay when they call you for the interview, 15, 20 minutes, they can find out you have any clue, yes or no. You know that. So it is very, very hard, you know. So I think the best you can do is what I do. I spend a lot of time at home doing a lot of coding, a lot of bunch of stuff myself, you know. So, for example, last month a client called me and said that he want to give it to me a project in R. How many of you have done R before? R. Nobody, all right? Me too. So R is good, and you're supposed to know something like that, all right? Let me give you some idea. Okay, so you need to know this point, all right? You need to know business statistics to do data science, yes or no? You have to do something, you know. You need to know Python, R, or Java. Any of these three is good. So I don't know R. So what do? Okay, I don't do nothing. I don't care about it, yeah? So last week, another guy called and said, I want you to do a project for me for 3 months, and I pay you $120 per hour for 6 months. So anybody do the math here right now? $150. So I said, okay. So what do I do? Well, I talked to my family and I said, you know, in August 1st, I'm going to spend 4-6 hours a day, not stop, get R Studio, and pass many tutorials online. I believe if I do that August, September, by the end of September, I should be ready to get project in R. That's what I do. That's what I'm going to do. Anybody want to do that? Do that. Don't sleep. Don't eat. we have no choice. I mean, sometimes I wake up in the morning, Saturday, Sunday, 4 or 5 o'clock in the morning, everybody in my house sleeping, you know. I can do a bunch of hours doing coding research. They go to bed maybe around 10, 12 o'clock. I stay maybe 2, 3 o'clock doing research. That's what you have to do. Because this class, the boot camp is good, give it to you an idea. Still, you need to write the code, you know, you need to digest it, you know. It's not like you can run Tensorflow for a couple of lines, you can get it. No, you don't. You need to do the interpretation, you need to practice, you know. That requires a lot of time, you know. Is that clear? A lot of time. So I want you to spend time with that, you know. So
you wake up at 4 in the morning and you go to sleep at 3 in the morning.
if I stay 2, 3 o'clock, I get sleep. But if I go to bed 11 o'clock, I put my clothes 6 o'clock in the morning. I close my door, have a batch of coffee, cup of shaf tequila in case I have to wake up. And so from 6, 7, 8, 9, they wake up about 10, 12, 11 o'clock. I have 5 hours alone in my house, learning a lot of stuff I don't know. And we have to do that. That's what I do. So you want to do that, do it, you know. So some people don't want to do that, but I do. So I want to make sure that I understand what I'm doing. So anybody want to do that? Business statistics, you need to know that. Python, R, Java is important. Why Java? Why people using Java for data science? Why? Anybody know that? Yes, number one. But number two, no, but that's not more important. That's not good. But why using Java?
So you can use Clojure to run all your Java?
Do what?
No,
What is that?
it's a bad joke, sorry.
Yes, that's what I thought.
Yeah.
Okay, very good. Okay, Case Permanent Hospital Java, Oregon State University Java, Prudence Hospital Java, because Python is slow, and they're using a lot of millions of record big data for image processing, and Python cannot handle it. So in this case, these people write everything in Java, and some people like mentor company from Wilsonville. They write the entire machine learning for the company in C++ because they have ton of terabyte record, and this guy, Python, and I cannot do nothing for them. So I just want to let you know that, okay? We good? So that's what we do.
I mean,
So-
you can write modules in C++ and use them in Python.
Right, so good question. Can I write this module in C++ in Python? Yes, you can do that. I can create jar in Java and call in Python. So the question is, why do you have to maintain this jar and all this stuff, Python and the communication? Why we don't write everything in Java and we done everybody learn Java for many years? So it depends. It depends what the company using, you know. But I just want to give you an idea. So if you know Java, you may find a company that do Java too, you know. So C#, Microsoft C#.net, some company do that. So check it out there, you know. And so machine learning, you have to learn about that. You know? So Tensorflow, under me, I want to show you something very important for you. What is the most popular machine learning framework? Tensorflow, no choice. The second one is Theano, the third one is Caffe, the fourth one is Torch, and the fifth one is the Neon from Intel. Very bad one. Is anybody from Intel here? Nobody, that's good. So, can I find a job machine learning without knowing Tensorflow? You can. You can do that. There's no way. You have to know Tensorflow. Or maybe you can do Theano, maybe you can do Caffe. But in general, Tensorflow is the main framework today to learn, and you need to know that. So, how do you learn that? You need to find out. So, let me show you a couple ideas here quickly before I do the code for you guys. So, Tensorflow is, that's a Tensorflow here. A couple of weeks ago, we didn't have this link here for Windows. You can run Tensorflow on Windows right now. You can use using CPU or GPU. You can see that. Very nice installation. And I believe they have tons of tutorial online here. Let me check it out. The developer. There's a lot of tutorial here you can learn. Contribution, how to start, algorithm, look at that, a lot of stuff. Getting started. So how to do installation, see that here? A lot of stuff to learn here. Is anybody teaching here deep learning, machine learning in this organization, all right? They do that? They do that or no? No? So you don't, yeah, deep learning, machine learning, you teaching here? Not in the program. Okay, maybe you should do that. So you're taking a boot camp, and we saw deep learning, machine learning is fun, right? You don't know nothing about that, but so please check it out. That Tensorflow is very important. It's created by Google. Andrew explained about that. It's the #1 deep learning framework for machine learning today, algorithm. You don't know that, you done. So very simple. You good?
Are they going to update it to Python 3.6?
I'm not sure about that because
It's already up. It's the build.
I see they already done for the
They
whole.
already have. Alright,
Yeah.
that's good.
I
As
think,
of last week it was.
yeah, it was so many complaints because they do for Ubuntu and from Macs, and was not in Windows. People complain over the place. So a couple of weeks ago they implemented for Windows too, you know. But run slow because you have to have a GPU, you know, NVIDIA. Without that you cannot run it. So yes, it's important to learn that. You know. Okay, I want to show one code here that I'm running. What is the most popular Python IDE today on the market? Most popular Python IDE on the market today? Eclipse? No. Huh? PyCharm?
Idle for lunatics.
Okay. The most popular, listen to me very carefully. The most popular Python IDE machine learning today is called PyCharm. You can download a free community edition online. It's kind for the company name JetBrains. It's the same problem again. Everybody up there using PyCharm. Can you find a job if you don't know PyCharm? Same problem again.
How do you spell that?
PyCharm, let me do for you right now. IntelliJ, let me do for you right now.
PY with the word sharp.
Charm.
Or char.
C-H-A-R-R.
See this one here, JetBrains. Please, I want you to download the free edition, community edition, install it, and use it from tomorrow, right away. Don't wait.
I use Spider.
Yeah, he uses Spider. He went to the company interview. They use PyCharm, and the guy said, "Okay, we have no Spider, my friend. So do you want to do Mosquito, whatever you want to use?" No, we need to learn what is available for the job. We need to know what's available for the job. We don't learn whatever I want, whatever people want. It makes sense? It's the company, many companies using PyCharm. If you put the resume, I do Python development in data science using PyCharm, you should know PyCharm. Because you don't know, they're going to wipe it out you on the interview. Very simple. We good? I'm telling you very clear stuff because I do that for living, you know. I find clients, find people all the time. For 24 years, I already learned my life that I need to learn what they offer me, not what I like here. We good? Okay. Okay, so let's move here. I want to show you something very simple right now. I'm using Eclipse IDE. I'm using something called PyDev. It's a plugin to do Python development, very old, very popular. So I want to show you how do we run this Tensorflow for a simple linear regression. And I want to show you one by one, line by line. So I want you to see everything like I'm doing right now. So as you can see here, I have this import TensorFlow TF, NumPy, very popular, and the Matplotlib library, these three here. So let me come everything. I want to write everything one for you right now. I want to come it down here and come everything down. So I'm going to create two variables, the x and the y. First one, I'm going to create a x string, and it's going to be NumPy line space. Let's go ahead and show you for you here right now. So let's run it. I'm going to create the x for the train. So this is the value. For what we're doing here right now, it's very simple stuff. I'm creating a simple NumPy array that's going to run between -1 and 1, and I'm going to have 101 value. It's just building the x value, that's it. Any question? How many of you have done before? NumPy before? NumPy is simple, right? Who never had done before NumPy? Never had done before NumPy before. Okay, this is not good for you. There are three main libraries in Python that you need to know. One is pandas. How many of you have not done panda before? Pandas? No panda before? Okay. Panda is the best Python framework data extraction manipulation that everybody needs to know. We're good about that, yeah? NumPy for numerical calculation, and the other one is like a SumPy and all this coming from the Python data stack. Okay, so this one here, what I'm doing right now is getting NumPy, getting the line space, start between -1 and 1, and give it to me 101 value. That's the array, am I right? Simple, right? Just beat the x values. Let me go back and get right now and get the x value right now. So I want to comment that, I want to get another one. Okay, so what I'm going to do, I'm going to build right now the y value. So what I'm doing right now here, I'm creating a y training multiplied by 2 and creating a simple linear equation, am I right? See that? X equal 2 times, y equal x times 2 times x, am I right? This one here, see that? So I'm going to add this a little bit noise, random variable, to make it kind of safer, you know, nobody linear, you know. So let's go ahead and run that for a minute here, you can see that quickly. So let's print that. We have this array right now. That's the value, and let's build the graphic. So I'm going to come here and show you the plot. So you can see that very simple plot, very nice. Put the back, put this one back, and let's run it. So, simple one. So, let's say you go to the client gives you the data, and they want to predict using linear regression, all right? You can see the X training and the Y training. Simple, right? So one of the machine learning algorithms for to do that is called the linear regression. I'm going to use the Tensorflow to do that for you. Exactly like Andrew showed in the slide, remember? Same code, same idea. So how do we simulate that? Let me go right one more time for a minute here. When I come back again. Okay, so how do we do that? For a minute. Cost function. So we can close here for a minute. Okay, so as you can see here, I'm going to declare two placeholders, y and x. You see here, am I right? Simple stuff. Going to be float variable. Very good. I'm going to create a new shared variable in Tensorflow net. It's going to be w, and that's going to be the weight. I'm going to start for 0.0 variable. And then I'm going to define the model. The model is going to be multiply x times w. See that here? I get the Tensorflow model. Everything is defined, remember? I didn't run anything at this time. And I'm going to define the cost function as a Tensorflow square between the model and the real value. And after that, I'm going to define, like Andrew showed in the slide, using the gradient descent optimizer with the 0.01 difference. I'm going to minimize the cost. Line 47. Same idea for the slider. That came for the slider. Everything came for the slider. I didn't do anything extra. Nothing new. See that? Any question between line 34 and 47? We're just creating all the variable model definition to run Tensorflow. We have to do that. Any question? Line 34 to line 47. Any question, let me know. So after I define everything that, I'm going to create a section in Tensorflow. So let's go ahead and do the work. So I'm going to come here, and I'm going to uncheck all these lines of code here right now quickly. All of them. So what I'm going to do right now, like Andrew explained the slide, I'm going to open a session running. You can see that which station. And because I had a variable w defined, I need to initialize. In Tensorflow, we do tf global variable initialize that run. Everything has to run. So what I'm going to do, I'm going to get a range, run 100 times, get all the value of whatever is in the training, in the X training and Y training, get the value of Y and I's, and run the optimizer, followed by the fit dictionary between X and Y. And when this is running and find the difference between them equal or less than 0.01, it's going to stop and it's going to give it to me this value here named W. That's going to be the slope of the question. After that, what we have to do is close it. So let me go ahead and run for you everything. As you can see here, if we define that the slope is equal to, by definition, this value has to be close to 2. Let's go ahead and run it. So we got that, and let's run it. So the first one is going to be, let's find out. So the first one is going to be, see, 2.01. You see that here? Very close, yeah? Okay, so let's go ahead and run again. Why too slow? Because I'm not running a GPU NVIDIA video card, and I'm running very high level of the graphic design in Tensorflow. So the next one should be, let's find out. You see, again, that's very close, isn't it? I ran only 10 iterations only. So let's do one more time. Find out. And 1.94, one more time, last time. Okay, back again, 2.00. Let me go ahead and run for you everything. So let's put this in back. Good. So we got that, we got the training, we showed the plot here. I need to put back the plot so we can see that on this line of code here. And let me find everything, and we're supposed to have the line very well defined. Let's run it right now. Let's find out. Got an error, show the plot. Sorry for that, and try again. That's the line. So I just simulate a linear regression. I give it the training model to the Tensorflow to calculate for me the new slope, and I calculate the prediction value. That's it. Very simple, all right? Exactly what I'm going to show you in the slide. It's same code. I didn't make anything happen differently. Okay? Anybody got to see the code one more time? You have any question? Let me know. Any question for me, please? So, can I use this code in production? Yes or no? How do I know that your Python code is good? Yes or no? Anybody knows about it? No? Nobody to you? The question is, can I use this code and put in production environment? Yes or no? How do you know that your code is good to use for client, for real life? How do you know that? Do you have an idea? Anybody teach you before how to do that before? No? No. Okay. So there's a lot of stuff between what people, data science people do in coding, and it's different what we do in production. You know. So in production environment, we are not using Jupyter Notebook. We're using PyCharm, a real program. We write unit text code to do that. We do a lot of continuous integration. So it's a lot of stuff what we do in production. There's something we show here right now. So we don't write code top to the bottom. We create object programming. We do class inheriting organization. We create libraries. So a lot of stuff is different, you know. So just want to make sure that this code is just for the demo, you know. We don't do none of this stuff in real life. You know, so.
I can't put my fast, dirty written code into the production system. It gave me the right answer.
So this is one example of the code I show you guys. Very simple stuff. Same like slide that didn't make anything happen for you, strange, you know. So Tensorflow is important. You need to know that. And any question for me? Questions? A lot of job, data science all over the place. A lot of job available. But you need to know that because they're going to call you for the interview, and the interview is about 15-20 minutes. And if you don't know statistics of the stuff, they take.
I'll just jump in. It's like the whiteboarding interviews. You know, if any of you have done that, you know, they make you do algorithms you did in college, but you would never do them in the real world. When it was applicable, there's already a library for it. So, I mean, plenty of you have ran into things like, you know, do a breadth first search on a tree. Well, that's not so hard. How about a balanced tree? Find the minimum spanning branch and stuff like that. You're just going, oh God, I haven't done this stuff since college. I'll never do it. But they're going to do it to you anyway. You go to a data science, it's whiteboarding too. It's going to be statistics. So you got to know your basic statistics.
Yes.
You, in the beginning, mentioned like to beef up your profile in your portfolio to do like free projects for somebody, but say you're having a hard time finding somebody to do a free project for whatever reason, or do you have any like good resources that you would recommend to go to kind of create your own sort of project to do in your free time?
Excuse me, you could have your answer, please.
Please don't answer.
What pops into my mind is one of our recruiting hats for working and making contributions to a bunch of people that work at OpenAI and Google, DeepMind, places like that. And we've actually done really amazing recruiting connections to top AI talk just by some that work with them on their OpenAI source on solid GitHub and then establishing that on email and meetings. So yeah, so
a great way to reach out. Pull requests are a great way to reach out.
Yeah.
No, but I think it's important. If you
Yeah,
go,
they're like, oh, you're
I
correct.
think I want you to
Debug
go.
this.
I want you to go every month to the Portland Data Science Meetup. I want you to go to the algorithm reinforcement meetup. There is a Python meetup too. Go to this meetup, sit down, meet people there. Make sure you have a business card, talk to them. Try to connect with people, with clients, and said, I would like to be involved. If anybody can provide for me some connection, some ideas, some good project for you guys for free. Say the word free so you get connect quickly, because you don't say that, they're looking at you very bad. and so that connection, am I right? Go ahead.
I'll offer it. There's a couple places you can go to for volunteer projects. Hack Oregon.
That's
I don't know
Hack
if you
Oregon.
guys have heard of that. That's probably the biggest one. What they do is they do stuff in partnership with the city of Portland with big data sets, making those data sets more accessible to the public, and visualization and machine learning, trying to do interesting stuff with city data. And they always have projects going on and looking for volunteers, so that's a good place to develop your data-driven skills, as they refer to it. Other entities are getting in the name. It would seem odd, but the Pacific Northwest College of Art, because they have a digital program, and they're trying to wrap it up. They have gotten involved with different civic entities. In this case right now, the Sandy River Watershed Commission, Sandy River Basin Watershed Commission. That's a long one. They're doing a civic project that launches July 14th, looking for volunteers, and what they want to do is recognize and track migratory birds. So they're going to be building sensors, putting them out in the environment, collecting lots of data, and they're going to learn from that data, so they're also recruiting data scientists. So you keep your eye out. What you see is a lot of civic type of entities have been collecting data with your taxpayer for a long, long time, and they're asking the question, like I gave you that example with the, with the business one, where the business guy comes in. Now, what can we learn from that data? And that's where these projects are starting to show up.
Oh, just you probably know Cornell Ornithology Lab is probably the best resource for migratory bird data tracking. They have great visualizations. Really fascinating.
I'll let them know if the NCA, but I'm sure they already do.
So to what I did 2 weeks ago, I have a friend that worked for the Hillsborough, for the school district, So, and I said, can you introduce me to the city, mayor of city Hillsborough, And I said, okay, so we have a meeting, So, of course, took a month to meet this guy, the guy, I don't know, the blah, 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 political guy, So I went there and I said, I'm a data science, I believe you maybe have some problem with any data department here. Could you please connect me with any of you? I will do some work for you for free, So I got a phone call from the guy 2 days ago, and he's going to connect me with the city of Hillsborough manager to go to the financial department and do some data mining for them starting next week for free. I can do maybe 6 hours a week, do that for fun, and we provide for them everything they need, and I put that in my resume. That's what I do. So, just an example,
Is that all the questions?
Questions? One more thing. Today, in machine learning, there is a problem with one thing that we do, and nobody has any clue very well. It's something called, I believe it's called for the image processing recognition. You can learn these things, and learn fast and good. You will find a lot of jobs doing that right now. There is a lot of healthcare industry, university labs that want to learn how to do this image recognition and do some classification and segmentation for specific types of the human body, whatever they do. And you learn to do that, you should be able to get very good connection to.
Yeah, I would agree. There's a lot of demand currently for computer vision. So even if you feel your resume is fragmented and doesn't have a good focus, but for some reason you got this strong strength right inside of it for computer vision, you'll still get a job.
Now this is very
It's really high demand right now.
So especially, you know, I mean, my idea is you don't know to do how to do that and have an idea how to do the image recognition processing. In the next couple of months.
You were referring to Tensorflow.
Yeah.
That would be very popular. You want to get up to higher ranks, more scientific, more researchy. You know, you want to get below the library level to be able to design these things. So, you know, we would be looking at, you know, being able to pull apart and put together contribution networks.
Any more questions for me? We good? Questions?
Well, let's give a hand to our How many of you really like machine learning now? Great stuff. Hey, I represent the Tech Academy, the building that we're in, and if any of you have an interest in learning programming, we also have a 15-week course that we cover a number of things, full stack oriented. And we also have people that are very interested in machine learning as well. It's not part of our official curriculum, but they creep in and enjoy the process. So Michael and I are happy to answer any questions for you. We also have a survey for all the people that first time here. We're happy to talk with you and answer any questions that you have.
And also, Brian is looking to hire, so
I'm hiring as many machine learning engineers as I can right now and other business functions that have required knowledge of machine learning. And my recruiting is being run through Scout Savvy, which is another Portland startup. Started exactly the same time I did in April. You can go on Scout Savvy. We're going to be the featured employer on Scout Savvy next week. Or talk to me and go on our website. It's x-r.ai. You can just pronounce it X-ray, and check out x-r.ai/careers and take a look. And you can click the email icon. You can tweet at us. You can fill in the sign up sheet. And we're going to extra effort to recruit and make this the best place in the world to work for, regardless of gender or ethnicity or anything. And feminism and diversity are core values for us. So, and Catherine, the CEO of Scout Savvy, she does tremendous bias correction and in her technology. It's really neat software for masking gender and ethnicity and things like that for the employers when they're reviewing talent. Anyway, so even sign up for a job interview and sell us on what you could do. And everything's moving extremely fast, and you can get in on the ground floor. And we're doing a Series A pitch here in San Francisco next month. We're in talks with the industry leader to help us with data engineering and to sell our products to throughout the world. And we have one of the biggest tech companies in the world and other customers signed up with us, and they are saying, "Wow, how fast can you take more work for us, and how fast can you roll out to China and Europe and Japan and Korea, because we need that immediately." So
go fast.
It's one of the highest growth startups in Portland, and you can get in on the ground floor with equity, and that's going to be really, really interesting. So please come talk to me.
Take an opportunity if you're still getting in, talk to them to learn more about it and see if it's
And if you're working on learning machine learning, recommend resources. The Andrew Ng machine learning class is free and it's terrific, and he's a world expert. And I think it's not as well known, but Michael Nielsen has a very short online tutorial called, I think it's neuralnetsanddeeplearning.com or something like that. If you Google Michael Nielsen, deep learning neural nets, he's extremely smart and very good at clearly helping you understand. So, yeah, anything you want to say about him? Yeah, I ran out, so it's an email I'm trying to answer. Yeah, I've been meaning to
One more reference would
been
be
meaning to
for
introduce
junior
myself
robots
for a
like
while.
I am in dynamic programming, reinforcement learning. The UK professor David Silver has some cartoons online. It's highly popular.
What's the name of it?
David Silver.
Let's go.
His lectures are a little bit grueling. They're an hour and a half long, and he makes his students stay 1 hour and 40 minutes. I have a big pot of coffee. You're gonna watch his lecture, but he's good. David Silver. It should be David Silver. Yeah.
Our headquarters is also, yeah.
I've never had problems finding them
You
before.
should email me and
So I would go reinforcement learning.
Yeah, University College London.
Yep, you got him. But his lectures are long, an hour and 40 minutes each.
That's good.
They're an hour and a half. He goes an hour and 40 minutes. Intentionally.
Just to see if you're still listening at the end.
And it's funny at the beginning. You always see, because it's the overhead, you see the students who come in 1-2 minutes late, and they're forced to go through the light, they're all hunched over.
Oh my God. I had some professors that would go 2.5 hours per lecture, and it got pretty brutal.
Well, hey, you need one of our Portland data science cards.
Yeah, we met at the library the other night.
Oh, good. Oh, you're Brad.
Yeah. That's right.
I see so many faces.
Yeah, thanks for the presentation.
Yeah, so he just quit as secretary as the chief AI person at Live. Before that, he was like so which one?
Zach. Yeah. What levels are you guys looking for?
We're still even trying to figure that out. We're just trying to find as many smart engineers as possible and other positions.
Okay. I'll give you my business card. I just ordered them today.
I literally had to run and pick them up from Staples on the way to my
But that's exciting. The business.
It's growing extremely fast. It's astonishing how fast it's growing after 2 months.
Do you guys have office space set up somewhere?
We do at the central office in Pearl, 13th and Everett.
Oh, okay.
Yeah, we're actually probably, they understand that we're going to be expanding there, probably start taking over multiple
No, I know
offices.
that office. I live at 10th and Lovejoy, so let's just go over and have coffee sometime.
Okay.
My stuff, I'll tell you when I see, but it's more on C#, so getting into this.
Awesome. Yeah, good to meet you,
Good to meet you, Brian.
Yeah, we'll definitely email each other and set up coffee in the next, are you free later today or tomorrow? Or?
I am, yeah. Just send me a text if it's later today, because I won't check email tonight, so.
Okay.
See you later.
Awesome, thanks. I ran out of the ones that I have on it, so that's my email and that's the
Awesome. Can I get a photo of that one?
Yeah. Chance around for photos.
I was going to say, or you can write them on the back of mine.
Yeah.
Yes. So,
I'll give you guys my Portland data science card. I encourage you to go to Meetup. Print up, we're volunteers, so they're printed on cheap paper on my email. There's a lot. We do a lot. We have a website.